Welcome to The Explainer. Today, we're diving into one of the biggest, deepest mysteries in all of science. Why does time only seem to move forward? So yeah, let's put on our detective hats because we're about to investigate a truly cosmic case.
All right, let's just jump right in with a question that on the surface feels almost childishly simple. But the answer? Well, the answer pretty much unravels the fabric of the universe. We can all remember the past, right? What we ate for breakfast, a movie we saw last year. But tomorrow? It's a total mystery. So why?
This constant forward motion, what scientists call the arrow of time, it's maybe the most basic thing we experience. It's the difference between a cause and an effect, a memory and a dream. Our entire lives are lived on this one-way street.
But this is where our mystery really begins. Because when we go and look at the actual rule book for the universe, I'm talking about the fundamental laws of physics. That arrow? It's just gone. It's completely missing. And that's a huge clue that something else is going on here.
And this right here, this gets to the absolute heart of the problem. Our experience tells us time is a one-way street, but the laws of physics, they describe a two-way street. You could run a film of a planet orbiting a star backwards, and the law of gravity would be perfectly happy with it. No difference at all.
And we're not talking about some obscure little rule here. We're talking about the heavy hitters, the most powerful and proven laws we have. From Newton's laws that let us send probes to Jupiter, to Einstein's general relativity that explains black holes, and even the bizarre world of quantum mechanics, none of them, not one, makes a distinction between past and future.
So this is it. This is the central question of our case. If the basic rules don't have a direction, why does absolutely everything we see and do and feel have one? We clearly need to start looking for a different kind of clue to crack this thing open. So our investigation is going to take a little turn here. We're moving away from the laws of motion and into a different corner of physics. And it's here that we find a really unusual suspect. This one isn't about how things move, but more about, well, how they're arranged.
And to get our heads around this, let's just use a super simple analogy. Something that happens in pretty much every kitchen. Think about an egg. It's a beautiful little system of high organization, right? The yolk is separate from the white. Everything is neatly tucked inside that shell. Very low disorder. And then you crack it open and scramble it. The yolk and the white get all mixed up in this random, chaotic mess. The system has gone from a state of order to a state of disorder. And that process, that change, feels totally natural. And more importantly, it feels irreversible.
I mean, seriously, have you? Of course not. It would be absolutely mind-boggling to watch a plate of scrambled eggs suddenly unmix themselves back into a perfect yolk and white and then leap back inside a sealed shell. This tells us something profound. Some things in nature really do seem to happen in only one direction. And this one-way journey, from order to disorder, from neat to messy, it actually has a name. Scientists call it entropy. Just think of it as the official measurement for randomness. A tidy bedroom has low entropy. A messy one? Well, that's high entropy.
But here's the thing. This idea of entropy doesn't just apply to eggs and messy rooms. It applies to the entire universe. And it might just be the smoking gun we've been looking for this whole time.
This leads us to the one single major law of physics that does have a direction stamped right on it, the second law of thermodynamics. It basically says that in a closed system, and for all intents and purposes our universe is one, the total amount of disorder, of entropy, can never go down. It can only stay the same, or much more likely, go up.
So the really crucial point here is that the entire universe is on a one-way trip. It started out in a state of incredible order and is constantly, relentlessly moving toward a state of maximum disorder. Scrambled eggs, a melting ice cube, a star burning out, it's all part of the exact same universal trend.
But wait a second. That brings up a pretty big question, right? If things are always getting messier, doesn't that mean they had to start out like super tidy? And that thought, right there, leads us to the final and most important piece of evidence in our case, the very beginning of everything.
And that is precisely what all of our cosmic evidence tells us. The universe exploded into being almost 14 billion years ago in the Big Bang, an event that was incredibly hot, incredibly dense, and, critically, in a state of extremely low entropy. That initial perfection was kind of like winding up a giant cosmic clock. And ever since that first moment, it's just been unwinding, with entropy constantly rising.
So, with all the evidence laid out, I think we can finally close the case on the mystery of the missing arrow. We found our culprit, and you know what? It was hiding in plain sight the whole time.
So it turns out the arrow of time isn't some fundamental law of physics in and of itself. Now, it seems to be what we call an emergent property. It's a consequence of the very specific way our universe began. We experience time flowing forward simply because that is the direction in which things get messier.
So, the main takeaway from all this is how a simple fact about the universe's baby picture, the fact that it was born in this state of unbelievable order, is what gives time its powerful, unstoppable, one-way direction. We can remember the past because the past had lower entropy, and the future is unknown because it's just a realm of higher, messier, more chaotic entropy.
And all of this leaves us with one final, kind of mind-bending thought to chew on. If time is really just a side effect of increasing disorder, what does that actually say about reality itself? Is time even real? Or is it just a grand story the universe tells itself as it slowly but surely unwinds? It's a question that shows just how deep this mystery really goes. Thanks for joining this explaining.